In this video, I'm going to be talking about computational social science and what it means, and we're going to understand that meaning with a computational approach. We're going to be looking at the structure of scholarly papers that include the term computational social science. And to do this, we're going to be using some tools of computational social science, including network analysis and text analysis at a very rudimentary level. Okay, so I want to begin by talking about, just giving you a very general introduction to bibliometrics. Bibliometrics is, the study of the structure of scholarship. And there are a number of packages that are available to use in our programming language that make use of this. And one of them is called bibliometrics, and we're going to begin with that as kind of a first take. So I'm going to share my screen here. This is the homepage for bibliometrics.org. And I'm going to be kind of just touching on some of the things that bibliometrics can do. I'll also be talking about some of the things that I think it's not really all that well suited for. In essence, there are two sides of bibliometrics. There is a package, the bibliometrics package that works within R. And in addition, there is an interactive app called BiblioShiny. And to run BiblioShiny, you don't need to be a coder, for no coders. All you need to do is open up a window in R, and in that window, you do need to make one line of code. So I've opened up R already. I'm going to scoot it over into this window, so you should be able to see it here. And this is the one command we need to use in order to invoke the BiblioShiny interactive interface. So let's go ahead and give that a shot. And this is how it begins, how bibliometrics begins. And there are kind of, I think we could talk about bibliometrics or the BiblioShiny app at two levels. The first level is to let it gather the data for you and to work exclusively within bibliometrics. So there are several public databases that are available. We're going to use PubMed here, and we're going to configure our API to look for the phrase, oddly enough. And 1990 to 2023 works for me. We could even go earlier, I guess. Let's see if there's anything earlier. Give it a shot. And we'll try this. And we get 146 papers, which we can download, and we're going to do that. Now, while this is proceeding, I'm going to tell you that this is not what we want, in a sense. It's going to give us something, but in order to get what we want, we're going to need to do a little more homework, okay? So let me scoot this. I actually can't scoot this window aside. These are the different fields in the bibliographic metadata, and they include author and DOI, the total number of references that in the paper, number cited references down here, publication year, and so forth. And we could see that for most of these references, everything is there, nothing is missing, but for a few fields, everything is missing. And among those things that are missing is the cited reference field. And we actually really want that. So what do we do? Well, we're going to need to gather data outside of the bibliometrics database and import it. So I'm going to close this out, okay? And we'll come back to something that looks like this in a second. Now I'm going to instead load data that I've previously loaded on my machine. I'm going to load a raw file from the Web of Science database. I have a separate video showing how I did this. I'm going to look for my file here. And where is it? It's going to be in there. And we've got Save Recs 1 and 2. Actually, I've got it up here. Okay. The bibliometrics only allows us, it's expecting things to be in one file rather than two, and I had them in two files on my desk, on my disk. This is just those two files concatenated together. So I'm going to start loading that in. And as we'll see, whereas before we had 145 or 146 files, here we're going to have many. Oh, no, we're not going to have many more than that. How many are we going to have? Let's see. Let's take a look. Oh, we do have. We have 794 files. For some of the files, we don't have keywords, but for most of the files, we don't have the keywords plus field. Okay, so but what we do have the abstract for all but a few of the papers. Okay, so let's go ahead and save that. If it will let me save that. Hello, there we go. And while it's trying to save this, let's try closing that. Ah, there we go. Okay, so my save command was an error. It was saving that as a table, and I'm not that concerned with that table. So that's what that was about. Okay, this is what our data look like. It is a rectangular matrix in which each row is a source paper in the area, and each column is a different field like author, etc. The most interesting field for my purposes is the cited references field, which is going to include all of the papers that are cited by that journal. And we're going to be using that to make a network to paint a picture of the field. So this is what our data looks like. And what I'm going to do here is I'm going to kind of spend a minute or two in this interactive interface in this video. So let's go ahead and we'll take a look. There are some characteristic features of the data. We can see that the field is growing, for example. Citations per year, let's see, there we go. Citations per year is not, that peaks earlier because you can't, because I'm not sure why. The 2009 was a big year for it, but the number of papers has increased kind of steadily up to 2022. And as of this writing, we're not yet done with 2023. Okay. There's some other graphs we could create here. I'm going to kind of skip over these. The main information for that, for the data, include all of these different things. We've got 35,000 references and so forth. And we could study these in tables. And we can generate all of these things within R as well. And there are advantages to doing that, including that when you work within R, your workflow will be reproducible in a way that it's not when we work interactively. The most relevant authors, these are the most prolific authors in terms of generating papers, I believe, is what they're using the word relevant to mean here. And it is taking its sweet time, and I apologize. There we go. Okay. Sandy Pentland, Simon Aral, okay, and so forth. In terms of the most cited, and this now I'm going back to the most prolific within this area in terms of the number of papers they wrote. I don't know why this is happening so slowly, but it is. Okay. So here we go. All right. So we've got, these are the authors who have published the most papers, which include the phrase, they come from where? They come from places like, it wants me to plot first, so it should go faster, Northwestern, Stanford, and so forth. And we could go through all these fields. I'm going to kind of skip over that. The most cited papers we could look at as well. This is not telling me really what I want to know yet. This is all about the nature of citations. And what I want to argue is that we can look at citations kind of more deeply. So if we'll just do one quick one here. Okay, the laser paper in 2009 with the 1,800 references kind of accounts for why there are so many citations from that year. All right. I'm going to come back to these words and so forth. I invite you to explore this shiny app side of bibliometrics, but I'm going to stop here because I want to talk about networks at kind of a deeper level. So I'm going to close out of bibliometrics, and I'm going to examine computational social science now using R code. And I'm going to make my font a little bigger here. Okay. And in this upper left-hand corner, we've got a source document where I'm using a few packages. I'm going to be using tables and so forth. And what I'm going to be doing here, let me clean out my the garbage on the machine. This investigation into the structure of computational social science. I'm looking at this in an RStudio document. I just moved into kind of WYSIWYG mode, which is memory intensive. And so sometimes it causes problems, but it's, it's nicer to look at. So let's stick with this. And we've got, this R Markdown document has got, like a Jupyter notebook in Python, it's got 3 different parts that could be knit together. One is explanatory comments, another is code, and the third is results. So we have these explanatory comments up here. We've got a little bit of code. We're bringing in these libraries. I'm not going to kind of go into detail about them. I'm going to run this chunk. I'm going to run things one chunk at a time. Then afterwards, I'm going to knit the whole document. And I'm going to look at that same set of documents that I just pulled up. And I'm going to look at them a little bit more closely. I've got some extra commands in here like debugging is false. If I'm looking at a data set with like 50,000 references, which I might be, I might want to first look at just a small fragment of that and set that to true. But everything is good here. And what I'm going to be doing is I'm telling it to look in a particular directory of my machine and to convert this bibliometrics data file, the one we just saw, into a data frame that R can have kind of a handier, is easier to see in R. So that's what that is. So let's actually just run that part of the code. I've selected and hit Control Enter there, and it's converting my World of Science collection into bibliographic data frame. This convert to DF command or function is part of bibliometrics, and it's pretty nifty. And now we've got this data frame here, again, which looks just like what we just saw in the BiblioShiny app. Each row is a paper. Each column is an aspect of the metadata for that paper. The one thing I'm most concerned with is the cited reference field. And so here, I'm going to do a few things, and I'm using this tidy syntax. And some of you who have been programming in R for a few years, you may not use tidy syntax. Tidy syntax is all about the pipe. The pipe can be understood as saying, and then we. So we take the data frame called bibliodf, and then we take the row names and we turn them into a column called source. And so let's do that here. And when we do that, well, I'm telling it to do it kind of interactively or on the whole data set. So this is what we get. That's all good. Anyway, I'm going to go back and go back a step because I want to kind of undo what I just did. I'm going to say we're going to take this. We're going to select only the source and cited reference columns, and we're going to just look at the first record just to get a sense of the beginnings of a network. And this is the beginnings of a network, the cited references in one paper, a paper that appears for whatever reason at the top of our file, paper by Hawks in 2017. These are the papers that were cited therein. They're separated by semicolons and so forth, okay? And these are going to be the elements of a network. We can think of two kinds of networks, and part of the reason why I wanted to get out of BiblioShiny and get into this, into my code and bibliometrics here, is to show you what I mean by the two types of networks. The first is a citation network. And so for the citation network, we're going to take this data frame and we're going to pull off just the first 4 records. And from that, we're going to pull out that cited reference field and get those and pull out the individual references using this COC matrix function, express that as a matrix, and then we're going to melt it. So here's what this looks like at step 1. If we go up just through there, our sum sources file looks like this. We've got each row here. We've got all those columns. Just pull that off. That's fine. It's kind of a neat matrix. The melt command is going to reshape this as, maybe it's going to reshape things. A reshape to melt. Okay. This is going to give us a list of edges. I don't know why. All right. And we're going to pull out. All right. We're going to pull out all of the references. Gee whiz. We've got this as a matrix. I'm going to pause for 1 sec here. Okay, I'm back. I think I just selected the wrong set of lines there. All right, so there were 2 steps. Remember that at this step, when we select just this part, we have this set of sources as a matrix, and this is what it looks like. Oops. Okay, I didn't select the pipe there. There we go. Okay, so we've got this matrix where each row is a paper, each column is a reference, and the 0 means the person didn't cite it, and the 1 means that the person did cite it. Okay, and then we're going to reconfigure this. Not selecting the pipe now. Now we've got it column-wise. We've got the source and the target and the value. And then all we're going to do is we're going to get rid of the zeros as the next step. Rename the 2 columns as 1 and 2 and lose the value column. So here, you can see this is what we have. Now we have 410 lines, 410 citations among these 4 papers. Okay. And then I'm going to count the citations for each reference. I'm going to do that because my objective here is just to simplify this matrix. So I'm grouping by citation, getting those that second field, and I'm only selecting the ones that are referenced more than once. And when I do that, I now have just 16 papers that have been cited by more than one of these 4 sources. Okay, and we can present that. This is what it looks like in a table. but much niftier is to present it as a graph. And when we look at that graph, we've got two levels in this graph. One is we've got the sources in pink, the papers that we pulled up, and then we've got the papers that are cited, okay? These cited and citing papers. These citing papers are exciting because it's computational social science. And so we've got these 4 source papers and these 1, 2, 3, 4, 5, 6, 7, 8 target papers. And the 16 citations come about because some of the papers are cited more than once. And when you look at this bipartite or two-level network, it's got a couple of characteristics. One is it's directed. Each line goes from one place to another, and those lines go back in time. Hornberg, 2021, only could cite papers in the past, okay? Leaving aside papers in press and so forth, but you know what I'm saying. You can only go back in time, this act of citing. Okay, so this citation network is of interest to people when they're putting together tenure portfolios, when they're coming up with measures of H-index, when we want to understand what the most important papers are. All of that's good, but it doesn't tell us about the structure of the field. And we could begin to understand the structure of the field by collapsing across this network, by only focusing on one of these sets of nodes. We could focus, for example, on the green nodes, and we could say that this laser paper and the Conti paper have something in common because both of them were cited by Baltar and Tornberg, and in that way focus on these cited papers. And that's called co-citation analysis, and some people like that. We're going to be looking instead at the pink nodes, looking at bibliometric couplings and collapsing over the green ones. And that's and so there's some text kind of summarizing this. The code will be available to you if it's not already. And we run this, okay? We take our network, and we actually are going to do one trick to it here. Let's see if I can, yeah, all right. So I'm going to go ahead and run this. This is the small mode raw data, and this is what it looks like. And as you can see, it's a symmetrical matrix. On the diagonal, we have ones, and on the off diagonal, we have fractions. And in this case, the way these data are expressed here, these values are proportions. So all of the references of Hawks are cited by Hawks, and 1% of Zhang's references are cited by Hawks, and so forth. Okay, and this in the background we've standardized, or rather normalized, to adjust for the fact that different papers have a different number of papers. But that's getting the weeds only a tiny bit. But I'm going to kind of skip over that. We're going to take this matrix and we're going to change those diagonal values to 0, because I'm not concerned with the fact that people share all the references with themselves. And then we've got, let's see, we've got that, okay. And so we can show our little table here, which is just basically our matrix. And then we're going to make another graph. And what does that graph look like? It looks like this. And there's a thick line between Baltar and Tornberg, reflecting the fact that they have 1, 2, 3, 4 references in common. There's a thick but a tiny bit thinner line between Tornberg and Laser, because they have 3 references in common. Excuse me, between Tornberg and Zhang. Okay, and then there's a thin line between Zhang and Hawks, reflecting their 1 reference in common. And there's no link between Hawks and Tornberg or Hawks and Baltar. And if we think about these papers, these scholarly things, these papers that people spend months or years working on in their different academic silos, there are different disciplines, there are different institutions, there are different countries publishing in different journals. We start to get a sense that Hawkes and Baltar are far from each other. Baltar and Tornberg are close. And this is the beginning of a map of the field. And so it's a beginning of an understanding of the structure of scholarship in computational social science. Now, if we want to look at, we can look at, again, the citation network as a whole, or the scholarly network as a whole. And I'm not going to go into all the code for that. What I'm going to do instead is I'm simply going to knit this document and then talk about the next step in the process. So in knitting, I'm making a report, which is going to have the figures and the tables, and any statistics knit into the document itself. Here it's being done in HTML format, and you'll see it pop up in a sec here. But basically what we're going to be doing is, I'm going to argue that bibliometrics is really nice for getting the essence of this network, but I'm going to go into an interactive application next to fiddle with my graph a little bit, because there are a lot of parameters that one can fiddle with in a graph. There are problems with interactive applications. Again, the process by which you get the result isn't reproducible. But nonetheless, I want to do this just to kind of illustrate what the network is going to look like. Okay, so as this kind of wraps up, and this is not a big network, but you can see it's still taking a few minutes on what is a fairly powerful laptop. All right, so 800 references. And this is our HTML doc that's knit from this. And we've seen part of this already. There's our site reference. There's our list of these 16 papers. There's our citation network, our small citation network. And then the small structural network expressed as a matrix and as a graph. And then what happens when we go from 4 papers to 794? And so there's a lot of statistics here on the citation network. By all means, check it out. The most cited, the most relevant source is Journal of Computational Social Science. I frankly think that that's probably a problem. It probably reflects on a poor selection of the phrase, that we would do better at getting a map of computational social science if we used other phrases as well. But despite that, this is just largely pedagogical. Most cited journals, PLOS One, PNAS, and the famous journal NA, which points out that there's a problem in the data. I suggest that you need to look at it, kind of clean things up. There's some code that sits in the background to do that. But here we have the beginning of a map of the network. And this is actually just 40 nodes, just 40 of the 800 papers in the field. You're not getting a lot of information here. What we can see is that it looks like there are at least 3 communities, maybe 4, that can be articulated here. But in order to really get a sense of what's going on in these fields, we need to do a few things. One is we need a better graph. 2, we need better labels for the nodes. And 3, we need a way to come up with, to understand what these communities are. And I think that for that, we're going to, the next 2 steps are, 1, kind of closer looking at the graph, and then the second is going to be some rudimentary text analysis. So that's going to conclude this video on kind of using bibliometrics. I'm going to move into using Gephi, our tool, next. Okay. So we've written the nodes and edges to disk, I should point out, and we're going to be importing those into Gephi. All right, end of this video and beginning of a next one.